Assalamu alaikum wa rahmatullah. Dear students, today we will start an important topic, important chapter from physical chemistry. The chapter is surface chemistry. It is the fifth unit from the physical chemistry. In this very unit, we have to discuss three important topics. The first, we have to discuss adsorption. It is AB, it is not AB, it is adsorption, one's point. We have the second topic, that is catalysis, and we have the third topic, that is colloids, remember this point. And as far as the examination is considered, question comes either from adsorption or from colloids, remember this point. First, we will try to define what is surface chemistry, remember this point. It is clear from the name that it is the branch of the chemistry. It will be the branch of the chemistry which deals with the phenomenon. It is the branch of the chemistry which deals with the phenomenon occurring at surfaces. Occurring at surfaces, or you have interfaces. This is the definition regarding the surface chemistry. It is the branch of the chemistry which deals with the phenomenon occurring at the surfaces. For example, we have the surface of the board. Dust particles come and they concentrate on the surface. It means that the concentration or accumulation of dust particles on the surface of the board, it is a surface phenomenon. Remember this point. It is the chemistry which deals with the phenomenon occurring at the surfaces. Remember this point, at the surfaces or interface. First, I will tell you which phenomenon occurring at surfaces. Which phenomenon occurring at surfaces. For example, I have already mentioned, we have, for example, adsorption. Adsorption means accumulation of particles of a substance on the surface of any object. That is adsorption. Remember this point. For example, accumulation of dust particles on the surface of the board, it is adsorption. Similarly, we have the second, that is corrosion. Corrosion also occurs on the surface. It is a surface phenomenon. Remember this point. We have the third one, electrode process. Electrode process. The process occurring on the electrode. Either it is the cathode or it is the anode. We have discussed it in the 11th class. You might have discussed in the electrochemistry that the phenomenon, the process is occurring on the electrodes. Either on the cathode or on the this anode. Electrode process occurs on the surface. On this point, we have the fourth, that is heterogeneous catalysis. Heterogeneous catalysis. It is the catalysis, we have also discussed this topic in this very chapter. It is the catalysis which occurs on the surface. Heterogeneous catalysis. It is the catalysis which occurs on the surface. Actually, what we have in heterogeneous catalyst, we have a solid catalyst, and gases come out, hydrogen plus, for example, we have nitrogen gases. They come and concentrate on the surface. These gases, they concentrate on the surface of the solid catalyst. It means that heterogeneous catalysis, it is a surface phenomenon. It is a surface phenomenon. It means that these are some phenomenon occurring at the surface. And the branch of the chemistry which deals with the phenomenon occurring at the surfaces, it is clear now, on the surfaces or interfaces, that very branch of chemistry which deals with these phenomena occurring at the surface or interfaces. I will also tell you what is meant by interface. We'll discuss it a little bit later. That very branch dealing with the surface phenomena, that is known as surface chemistry. Remember this point. We will here mention the definition of surface chemistry. It is the branch It is the branch of chemistry. It is the branch of chemistry. Remember this point. It is the branch of chemistry which deals with the phenomena, which deals with the phenomenon, occurring. I will mention here the phenomenon. For example, we have the adsorption. We have the corrosion. We have electrode process occurring on the electrode. That will be either cathode or anode. Electrode process or heterogeneous catalysis. Etc. These are some phenomena. For example, we have dissolution process, we have crystallization process. They also occur on the surface. On this point, it is the branch of the chemistry which deals with the phenomenon. You have to mention these phenomenon occurring at surfaces. Surface, it is clear there is no problem of surfaces, or we have interfaces. Or we have the interface. This is the definition of surface chemistry. It is the branch of chemistry which deals with the phenomenon occurring at the surfaces or interface. Surface means we have the surface on the board. We have the surface of electrode. Remember this point. Now I will tell you what is meant by interface. We will talk about interface. When we talk about the interface, it is the boundary. It is the boundary between two bulk phases, between two immiscible phases, or you can say substances. When we talk about the interface, it is the boundary between the two immiscible phases. If you have two immiscible substances, for example, if you have kerosene oil in water, kerosene oil will lie on the upper part. It will be the kerosene oil, and we have the water. They are immiscible. A clear boundary will be between these two phases, kerosene oil from upper side and the water from below side. There will be a clear cut boundary between these two immiscible phases. This boundary, this separation, this wall between these two immiscible phases, this boundary is known as, it is interface at this point. Or if you have, for example, if you have stone in water, if you have sand particle in water, stone and water, they are immiscible. There will be a boundary between these two. Stone, that is solid, and we have the water, that is liquid. Between these two phases, between these two immiscible phases, there will be a wall, there will be a boundary. That boundary between the two immiscible phases, that is known as interface. Remember this point. It means that it is the boundary between the two immiscible phases. When the two phases are immiscible, when the two substances are immiscible, that can be liquid solid, that can be liquid liquid, that can be, remember this point, solid and we have the gas, or we have the solid and we have the gas and liquid. Immiscible phases, the two phases should be immiscible, and there is a boundary. That boundary is known as interface. But you have to remember here, there is no interface in case of gas, because gases are completely miscible. If we talk about the gases, they are completely miscible. It means there will be no interface between the gas molecules in the gas phase. Remember this point. It is the boundary between the two immiscible phases or substances. You have to mention there is no interface. There is no interface between the gas molecules, as gases are completely miscible. Gases are completely miscible. You have to mention this. Miscible. Completely miscible. It means that if you have two immiscible phases, there will be a boundary. That boundary is known as interface. Some phenomena occurs also at the interface. It means that the phenomena either occurring on the surface or on the interface, that is a surface phenomena, and the branch dealing with the surface phenomena, that is known as surface chemistry. This interface, it is represented. Interface is represented. How you can represent it? Interface is represented by hyphen, remember this point, or slash. It is hyphen or it is the slash. For example, if you have solid stone in water, you will have solid, you can mention liquid. These two are immiscible. And this hyphen, it represents interface. Or you can write it also solid slash liquid. It means that interface, it is represented by either hyphen or by the slash. Remember this one. Now, how you can define the surface chemistry? You have to remember first the definition of surface chemistry. It is the branch of the chemistry which deals with the study of phenomena occurring at the surface or interface. Remember this point. You have to also mention the examples of the phenomena occurring at the surface or interface. We have the corrosion, we have the adsorption, we have electrode processes, we have heterogeneous catalysis. You can also mention dissolution process. You can also mention the crystallization process. Crystallization also starts from the surface, occurs at the surface. You have to mention, this is the definition of surface chemistry, the branch of the chemistry dealing with the study of surface phenomena. Now we have the first very important topic, that is adsorption. This is the first topic, that is adsorption. We have to mention the first topic, that is adsorption. That's fine. Now we'll discuss first the adsorption. It is a surface phenomenon. Surface phenomenon. This is the first point. Phenomenon. Adsorption is a surface phenomenon. We will see how we can define adsorption. Definitions of adsorption. What is the first? How you can define adsorption? Definition first. It is simply accumulation of particles, molecules of a substance on the surface. For example, dust particles lies in the air. If you will come in this very room after 20 days, after 30 days, you will find that the dust particles get accumulated on the surface, get concentrated on the surface. This accumulation or concentration of molecules of a substance on the surface or interface, that is known as adsorption. This is the definition first. It can be defined as accumulation or concentration of molecules of a substance on the surface. What happens when the molecules of a substance gets concentrated on the surface? The concentration of the molecules of the substance will be high on the surface than in the bulk. For example, if you have dust particles on the board, now what will be the concentration of dust particles on the board? It will be high than in the bulk. Than in the bulk of the board, concentration will be high on the surface. This is the definition. It can be defined as accumulation or concentration of molecules of a substance on the surface. Remember this point. Resulting into high concentration, you can mention this, resulting into high concentration, of molecules, on the surface, than in the bulk. You can mention this. Because adsorption is a surface phenomenon, it occurs on the surface, and when the molecules of a substance get absorbed, get concentrated, accumulated on the surface, their concentration on the surface will be high than in the bulk, than in the interior of the substance. Remember this point, concentration will be high on the surface. In the definition first, accumulation or concentration of molecules of a substance on the surface, resulting into high concentration of molecules on the surface than in the bulk. Now, in the definition, you can also mention it is interface. I can mention definition second. It can be also defined as concentration of molecules of a substance on the interface. But when you talk about the interface, you have to mention between two immiscible surfaces. A concentration of molecules of on the interface, but while the interface lies between the two immiscible substances, it means that particles can also get absorbed on the interface. Remember this point, and also get absorbed on the interface. I will take the third definition. Definition third. Remember this point. We have the third definition. Or you can take the example of second definition. What is number interface? For example, if you have kerosene oil and water. Remember this point. Kerosene oil and water. They are immiscible. This one is inorganic. It is polar solvent and it is non-polar. It has less polar character, non-polar. Hence, they are immiscible with each other. If you add soap into this mixture, kerosene oil and water, this is polar, this is non-polar, you have soap, or C double bond O minus. This is the way. If you add soap into this, what will happen? R parts will remain in the kerosene because it is non-polar part, this is polar part. What will happen? Polar part will remain in the water, non-polar R part will remain in the kerosene oil. It means that the soap molecule will accumulate on the interface as. This is the way. So molecules will accumulate on the interface. This is the interface. R part will remain in the non-polar kerosene part, and polar C double bond O minus polar part will remain in the water. It means that soap particles get accumulated on the interface. You can also remember this example. Now we have the third definition. Definition number third, how we can define? It can be defined as a phenomenon of attracting. The surface of board attracts the dust particles. First it is attraction, and then it retains the dust particles on the surface. There are two things. One is attraction. So dust particles get attracted towards the board. When they reach the board, then they get concentrated, then they remain on the board. After this contraction, after the attraction, then they retain. The dust particles get retained on the board. There are two things. One is attraction and second is retention. You have to mention this definition. It can be defined. It can be defined as a phenomenon. Phenomenon of attraction and then retention can be defined as a phenomenon of attraction and then retention of molecules of a substance. First, the particles are being attracted, then they are being retained. Retention of molecules of a substance on the surface. You can also mention resulting into high concentration. Of molecules on the surface. In simple words, you can mention it is the phenomenon which involves attraction of molecules of a substance and then retaining the molecules of the substance on the surface, resulting into the high concentration of molecules on the surface. These are some definitions of adsorption. In simple words, you can mention it is the phenomenon of accumulation, concentration of molecules of a substance on the surface or interface. This is a simple definition of adsorption: concentration or accumulation of molecules, that is vapor dust particles, of molecules of a substance on the surface, or you can say interface. It means that during adsorption, two things are being involved. One is the molecules of a substance which get accumulated. The second, on which accumulation takes place. You have two things: the molecules of a substance which get accumulated, that is known as adsorbate, and the surface on which accumulation process takes place, it is known as adsorbent. Remember this point. I will mention certain important terms in surface chemistry or in adsorption. You can mention, we have the first, adsorbate and adsorbent. Adsorbate means dust particles which get accumulated. That's adsorbate. Adsorbent means the substance on which accumulation takes place. That is the board. Dust particle means adsorbate and the board means adsorbent. You can mention the substance whose molecules gets adsorbed, whose molecules gets accumulated. You can mention accumulated. Whose molecules gets concentrated or accumulated. The substance whose molecules get concentrated or accumulated is known as adsorbate. Around this point. On the other hand, the substance on which accumulation takes place, accumulation of adsorbate takes place, that is adsorbent. The substance, I will now define adsorbent, the substance on the surface of the substance on which the substance on which accumulation of adsorbate molecules takes place the substance on which accumulation of adsorbate molecules takes place is known as adsorbent. It means that dust particles mean adsorbate the surface of the board on which dust particles get accumulated. That is known as adsorbent. Remember this point. Adsorbate, and we have the adsorbent. Remember this point. For example, dust particles get adsorbed on the board. Dust particles means adsorbate, and the board, surface of the board, it means adsorbent. Remember this point. Now, the reverse process. If you try to remove the dust particles from the board, for example, this is the reverse process. We have removed dust particles from the board. The reverse process, that is the removal of adsorbate molecules from the adsorbent surface, that is known as desorption. You can mention third term. The first, adsorbate and adsorbent. We have the next one, desorption. Desorption means reverse process. If you try to remove the dust particles from the board, adsorbate particles from the adsorbent surface, this reverse process is known as desorption. The reverse process of adsorption. That is, what is meant by reverse process of adsorption? A removal of adsorbate molecules from adsorbent surface. Removal of adsorbate molecules from adsorbent surface is known as desorption. How you can carry desorption? It can be carried. You have to later on discuss it also. It can be carried by either decreasing pressure. For example, gas gets adsorbed under pressure. For example, gas molecules gets adsorbed on the board under high pressure. But if you decrease the pressure, gas molecules will come out. It means that by decreasing pressure, desorption process can be carried out. Either by decreasing pressure, or by increasing temperature, or you can say, or decreasing pressure, or by heating. Remember this point. Either by decreasing pressure or by heating. What is by heating? For example, this is the adsorbate particle. When it gets adsorbed on the surface, there is some degree of force, either weak or strong. We will discuss later on physical and chemical adsorption. But when there is interaction between the adsorbate and adsorbent, if you increase temperature, the interaction will decrease. The bonds will break down, whether van der Waals are the strong bonds. What will happen when the interaction between the adsorbate and adsorbate decreases, the adsorbate will come out. It means that how you can bring the desorption, there are two modes, there are two ways, either by heating, either by decreasing pressure. When you decrease pressure, gas will come out. adsorbate molecules will come out, or by heating. When you increase temperature, interaction between the adsorbate and adsorbent will decrease, and the adsorbate molecules will come out. It means that you have three terms so far. We have adsorbate, the substance, the molecules of the substance which get accumulated, that is adsorbate. The substance on which adsorption process takes place, मान लीजिए बोर्ड यहाँ पे है, that is adsorbent, and the reverse process of adsorption, that is known as desorption. Remember this point. Now we have, remember this point, you can also mention if gas gets adsorbed on the metal surface. If the gas gets adsorbed, for example, adsorbate is gas, adsorbent is metal surface, iron, copper, whatsoever, metal surface. Adsorbate is gas, adsorbent is metal, that is known as occlusion. Remember this point, you can mention the fourth term, occlusion. Occlusion, what is meant by occlusion? The fourth definition, the adsorption of gas molecules, adsorption of gas molecules on the metal surface, on the metal surface is known as occlusion, So far you have to mention certain things. What is surface chemistry? It is a branch of the chemistry dealing with the surface phenomena. You have to mention surface phenomena. Corrosion, electrode process, heterogeneous catalysis, adsorption. They occur on the surface phenomena. They occur on the surface or interface. What is interface? Interface is the boundary between the two. It's the contact between the two immiscible phases. Remember this point. Then we have discussed four definitions so far. Adsorbate, the molecules of the substance which get accumulated. The adsorbent, the surface on which adsorption takes place. We have the reverse process, that is desorption, and we have the occlusion, when the adsorbate is gas and adsorbent is metal. At that time it is known as occlusion. Well, that's fine. Now we will take some examples of adsorption. Examples of adsorption. Examples of adsorption. Examples of adsorption. You can say accumulation of dust particles. Accumulation of dust particles on the board, on the whiteboard, or you can say the back. It is adsorption process. The second example you can take, if when a dye solution, colored solution, when a dye solution means colored solution. When you have dye, colored solution, when a dye solution comes in contact with charcoal. Here charcoal is adsorbent. Remember this one. When the dye solution, colored solution, comes in contact with charcoal, it becomes colorless. Dye solution, colored solution, it becomes colorless. Why? Why it becomes colorless? Because dye particles gets accumulated. Because dye particles gets adsorbed. Dye particle means adsorbate. Dye particles means adsorbate. Gets adsorbed on charcoal surface. surface. For example, if you have a dye solution, colored solution, you have dye particles in the solution, and if you keep charcoal piece in the dye solution, what will happen? What will happen? The dye particles will accumulate, will be concentrated, will be absorbed on the surface. When the dye particles get accumulated on the surface, the dye solution will become colorless. It is a adsorption here. Dye particles get absorbed on the charcoal. Charcoal is adsorbent here. Remember this point. You can take the third example. The air becomes dry. The air becomes dry. If you have moist air becomes dry. If you have moist air, it will lose the moisture. That definitely means it will become dry. The air becomes dry. That is, it will lose moisture. Moisture when it comes in contact, when it comes in contact with silica gel. Silica gel is another important adsorbent. Silica gel, SiO2, silica gel, amorphous form of silica. Remember this one, silica gel, it is adsorbent here, SiO2, silica gel, and it comes in contact with silica gel. Because what happens? Because water molecules get adsorbed. Water molecules. Here water molecules are adsorbed. Here water molecules gets adsorbed on silica gel. For example, if you have moist air anywhere, for example in the room, if you keep silica gel here, what will happen? The room will become dry. Why it becomes dry? Because the water molecules gets adsorbed on the silica gel. Remember this point. You can remember these are some examples of adsorption. How you can define the adsorption: accumulation or a concentration of molecules of a substance either on the surface or interface. Remember this point. You can mention here examples of adsorbents. We have mentioned some examples. Adsorbate can be anything, dust particle, it can be either the gas, it can anything, but I will take the examples of adsorbents. I have mentioned charcoal, form of carbon. We have silica gel. You have metal surfaces. You can also alumina gel. You can have also colloids. Colloids can also act as adsorbents. You can mention these examples, but commonly used are charcoal, and we have the silica gel, or we have the metal surfaces. It means that so far you have discussed, you have mentioned certain important points: surface chemistry, adsorption, desorption, adsorbate, adsorbent, occlusion. Remember this point, and you have to mention the examples of adsorbents so far. Now we will discuss what is difference between adsorption. We have discussed it now, adsorption, and you might know absorption. And we have absorption. We will see what is the difference between adsorption and what is the difference between absorption, absorption. When we talk about the absorption, it directly means the molecules enters into the bulk. And when we talk about the adsorption, it directly means the molecules remain on the surface or interface. Remember this point. Well, we can say adsorption. First, we talk about the adsorption. What are the points of adsorption? Adsorption refers to the accumulation of adsorbate molecules. Adsorbate molecules, we have discussed this, refers to accumulation of adsorbate molecules on the surface or interface. Refers to the accumulation of adsorbate molecules on the surface or interface. What happens in case of absorption? In absorption refers to the entering the molecules of a substance into the bulk of the adsorbent, into the whole body of the adsorbent. It means that adsorption molecules remain on the surface, but in the absorption molecules enter into the whole body of the adsorbent. Remember this point. It is clear. It is a surface phenomenon, while the adsorption, it is a bulk phenomenon. Remember this point. Adsorption, for example, if you have the board, remember this point. For example, if you have metal surface, I will take the metal surface here because we have mentioned it in the examples that metal surface can be adsorbent. For example, if you have metal surface, we will discuss it in the mechanism of adsorption. There are free valencies on the surface. It means that the nickel present in the interior, they are stable, they have satisfied valencies, but the nickel atoms present on the surface, they have unsatisfied valency. And because of this unsatisfied valencies, instability, it will prefer to attract the molecules on the surface. This attraction, then retaining the molecule, that is adsorption. This adsorption, it is an instantaneous process. Because of instability, because of unsatisfied valency, it is an instantaneous process, that is a fast process. But when you talk about the absorption, molecules enter into the bulk, but slowly. It is a fast process, it is a slow process. Remember this point, you can say, as far as the adsorption is considered, it is an instantaneous process. It is an instantaneous process. Instantaneous process. What is meant by instantaneous process? That is, it is a fast process. It is a fast process. It is a fast process. But what we have to remember in case of absorption, that is a slow process. What happens in case of adsorption? Initially all the sites, all the valencies are free. It means that initially the rate will be high. For example, gas comes out, initially all the valencies are free, unsatisfied. It means that initially the rate will be high. But with the passage of time, when the valencies get satisfied, what will happen? With the passage of time, rate gets decreased. But in case of absorption, it occurs at a uniform rate. The rate is constant, it occurs at a uniform rate. But what is the case in case of adsorption? Initially the rate is high. Why? Because initially all the sites are unsatisfied. But with the passage of time, when some balances get satisfied, what happens? Then the rate gets decreased. And finally what happens? A stage reaches, that stage is equilibrium. The number of molecules coming toward the surface will be equal to the number of molecules escaping from the surface. It means that in this case, in case of adsorption, equilibrium process is attained, but in this case, it occurs at a uniform rate and there is no case of equilibrium. That's fine. We can also mention it is an instantaneous process, it is a fast process. You can mention initially the rate is high. Initially, I have mentioned it, why initially the rate is high. Initially the rate is high. Initially the rate is high, but with the passage of time, what happens? Rate decreases. Finally, what happens? जितने मॉलिक्यूल एब्जॉर्ब होंगे उतने ही डिसॉल्व होंगे. Finally, equilibrium will be attained. Finally, equilibrium. It is the case of physical adsorption. We will talk of it in the physical when we discuss the types of adsorptions. Finally, equilibrium stage will be attained. Stage will be attained. You have to mention this. It means that in case of adsorption, you have to remember 4 points. The first is molecules get accumulated, concentrated on the surface. Second, it is a surface phenomenon. Third, it is a fast process. The fourth, initially the rate is high, but the rate decreases. If you consider now absorption, it is the 4 points are opposite. In case of absorption, the molecules enter into the whole body of the adsorbent, into the bulk. It's a bulk phenomena. The rate is uniform. Remember this point. The rate is uniform in case of absorption. I will make a column so that you can remember this distinguish between this adsorption and absorption. In the column first, for example, we have simply discussed adsorption, and here we have absorption, and we have absorption. You can mention 4 points are there. First point, particles get accumulated on the surface or interface. Remember this point. In this, the particles enter into the bulk, or you can mention, or into the whole body of adsorbent. Here the particles remain on the surface. वहाँ पे क्या होता है? They enter into the bulk. You can mention the second point. It is a surface phenomenon. You can mention it is a bulk phenomenon. You can mention 2 more points to understand this. Third point, it is a fast process. Because of instability, unsatisfied valencies, surface tension. It is a fast process. It is a slow process. You can mention the 4th point about the rate. 4th point, initially the rate is, I have mentioned already, initially the rate is fast, initially the rate is high, but with the passage of time, it decreases till the equilibrium state is attained. You can also mention it till the equilibrium state is attained. What you have to mention here, it occurs at a uniform rate. Here the rate is, it occurs at a uniform rate. You can mention in case of, it means that in case of absorption, the rate is uniform. It occurs at a uniform rate. Now I will tell the examples, mention certain examples where you will clear the adsorption and absorption. For example first, ammonia gas gets absorbed. Ammonia gas gets absorbed on charcoal. Remember this point. If the ammonia gas comes in contact, it gets absorbed, but will be absorbed. But will be absorbed. यहाँ पे absorbed by water to form ammonium hydroxide. This is the first example you have to mention. If the ammonia gas comes in contact with the charcoal, it gets absorbed. There is adsorption. But if it comes in contact with the water, it gets absorbed and it forms the ammonium hydroxide. It means in this case it will enter into the bulk and it will form ammonium hydroxide. It is adsorption, it is absorption. Remember this point. Similarly, I will mention the second example. Water vapors. If you have water vapors in the room, water vapors gets absorbed by silica gel. Silica gel is this adsorbent silica gel. It means that if you have silica gel in the room, water vapors will be adsorbed, will remain on the surface. But will be now we talk about the water molecules, but will be absorbed, absorbed by anhydrous calcium chloride. If you have an anhydrous calcium chloride, what will happen? At that time, water molecules will enter into the bulk. At that time, it will be absorption. But if water vapors come in contact with silica gel, at that time, there will be adsorption. They will remain on the surface. But when molecules remain on the surface, at that time, it is adsorption. But when they enter into the bulk, at that time, it will be absorption process. It was a simple difference between adsorption and absorption. And when both the processes takes place, when adsorption is followed by this absorption, first there will be adsorption, then the molecules will enter into the bulk. At that time, it is known as sorption. At that time, it is known as sorption. Inshallah, we will discuss more important terms in the next lecture. So far, you have discussed, you have to mention what is surface chemistry, what is adsorption, what is adsorbate, what is adsorbent, what is desorption, what is occlusion, adsorption versus absorption, examples of adsorbents. And in the next lecture, inshallah, we will discuss certain important points regarding the sorption, positive, negative adsorptions, and inshallah we'll discuss these things in the next lecture. Till then, fi amanillah.